Hello everyone. Good morning, good afternoon, and good evening. Myself, Shashwat Tripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025 Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held on 15 December 2025 in Jaipur, India, and the virtual event is being held through Zoom yesterday and today, that is 16th and 17th December. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. On 9th minute, I will raise a very gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write on the chat box. Just before we start the session, I would like to introduce you to the chair of this session, Dr. Manoj Limchand Bangare. Sir is a head of department and an associate professor at Srimati Kashibai Naval College of Engineering, Pune, India. His research interests include cloud computing, task scheduling, algorithms, and artificial intelligence. He is actively involved in advancing research and innovation in intelligent computing and optimization techniques. Sir, would you like to share a quick opening remark?
Yes. Thank you, Ashwat sir. Am I audible?
Yes, sir.
Yes. So thank you for inviting me for this ICTCS as a session chair. And I also congratulate the all participants whose paper have been selected and they have reached to this one of the milestone to present their paper in this digital platform Zoom session. So I congratulate all the participants and all the best for the presentation. Yes, thank you.
Thank you, sir. Now I would like to start with the papers. Sunadhya paper title A Hybrid Deep Learning Architecture Combining Mobile Net and Custom CNN for Improved Maize Disease Classification. Sunadhya, are you there?
Yes, sir. Yes, sir. Am I audible, sir?
Yes, you are audible. You may please begin with your presentation.
Okay, sir. Thank you very much for your welcome note. Sir, can I share my PPT? So, a very good evening to one and all. So I am Sunanda Edla. I am a research scholar in Department of CSC in Geetham deemed to be University, Hyderabad. So today I'm going to tell about a hybrid deep learning architecture, combined net mobile net on custom CNN for improve on MISA disease classification. So once again, I'm repeating a very good afternoon to one and all. So today world, a plant disease pose a serious challenges to agriculture productivity, especially in a staple crop like maize. With the rapid advancement of deep learning, convolution neural networks have become highly effective for the image-based plant disease detections. So in this work, I propose a hybrid deep learning model that combines a pre-trained mobile net with a custom CNN to improve the accuracy of MISA leaf disease classification. Mobile net is used to extract deep semantic features using pre-trained ImageNet weights, while the custom CNN lends a task-specific features effectively. So in this model is evaluating using MISA leaf images from the plant village datasets, which include both healthy and diseased samples. So this experiment results shows that proposed hybrid approach achieves the significant improvements in accuracy, precision, and recall compared to the traditional single model CNNs. So here I'm giving the what is my paper ID, my paper, whatever the title. So that is justifying the MobileNet and custom CNN. So by this combined hybrid model, so we can overcome the traditional CNN models. So this is my basic abstract of the paper. So coming to the introduction. So in the plant disease, every time the plant causes the 20 to 40% of the crop loss globally, this is threatening the food security. So here in MISA is a staple crop where early disease detection is very critical. So traditional disease identification relies on expert visual inspection, that is time consuming, subjective, limited expert availability in a rural regions. So an image-based automated detection offers a scalable solution. So here the CNN-based AI model achieves over 90% accuracy in a plant disease classification. The deep models like Reset, VGG are accurate, but computationally these are the very expensive. So here the mobile net is a lightweight and very efficient, suitable for the mobile net and real-time use. MobileNet alone may miss the dataset specific features, but whenever we are going with our hybrid model, that is a MobileNet with the custom CNN. So it combines its generalized features with the task specific learning. So this experiment shows a improved performance over the standard models on MISA disease data. So here some related works, the previous related works also there. Some are working on the higher this is a disease classification. Higher temperature also will affect our MISA. So the disease severity also will increase. And some more papers gave some data that is a deep CNN model such as VCZ, Reset, Renet, and Inception models. All these are giving the less accuracy. So depending on this, I'm going with the proposed system that is a combination, that is a hybrid MobileNet and CNN model. So coming to my proposed method. So the input MISA, here I'm taking the leaf images as a corrected from the standard data sets. So this is my proposed methodology. In this, I'm starting with the data collection. Excuse me. The data collection is collected from the plant village data sets. And after that, I'm going with the data pre-processing. In the data pre-processing, the image resizing, normalization, data augmentation. So here in the train data and validation data. So the train data is 80% and validation data is 20% I'm taking. So after that, the training data set I'm giving to the hybrid model, that is a pre-trained mobile net plus custom CNN. So after analyzing performance, I'm getting some accuracy, precision, recall, and F1 scores data sets. So this performance analysis finally will work on the corn disease prediction. So finally, the classification will be like which type of disease the corn leaves are affected. So that is maybe blight or common rust or gray leaf spot, healthy. So the output will be the among these four. So the data sets, whatever I'm giving the data sets are in the images format. Few of data sets are in blight disease, few of are common rust, or few are some healthy leaves, some are gray leaf. So most of the data sets I got are these are the four. So that's why initially I worked on these sample images. So these are the classes which I mentioned in the data sets. So here a data pre-processing, what I mentioned in my proposed model. So this is the data pre-processing, image resizing, normalization, and data augmentation. So these are the data pre-processing techniques I used in the data pre-processing, that is image resizing and normalization. So in the image resizing, all images were resized to 224 by 224 pixels. So this is a prescribed size for we are giving to the model image resizing. Normalization is
Dhruv
pixel
mentioned a
values.
group of institutions.
Sir,
Oh,
normalization is a pixel values were scaled from 0 to 225 to 0 to 1. By dividing 255, the improved training stability and convergence. So finally, the data augmentation is the real-time augmentation was applied on during training, including random rotations plus or minus 30 degrees, horizontal flipping share 0.2 and zoom 0.2. So like that, rotations, horizontal flipping, zooming, everything as applicable to the real world variations. So this is about data pre-processing, and coming to the proposed hybrid model architecture. So here mainly I use the mobile net feature extractor custom CNN. So the mobile net feature extractor is mainly focusing, it is a very lightweight backbone of initializing the image net pre-trained weights. For suppose here it is taking the classification layer, it is customizing and very pre-processing features it is extracting. If the uh, and drop layer and it is overcoming of the overfitting also. Coming to the custom CNN, these three here in the custom CNN, there are three convolution layers are used. Those are 32, 64, and 128 filters and ReLU activations also. And max pooling is reduces spatial dimensions, captures the low and high level features, and output the flatter and pass the dense layers, and followed by the dropouts. So all these are together. Finally, we are getting the hybrid integrations. And finally, the third one is the final hybrid integration technique. Input images processed by the both mobile net and custom net. What are the previously discussed mobile net and custom CNN? So here the input processed by the both mobile net and custom CNN in parallel. Feature maps the flatter pool and these single features vector depending on this hybrid integration. So together, finally, we are getting a high level semantic and task specific local features for, we are getting the task specific local features. By these features, we can easily identifying the which leaf is affected and which leaf is not affected. So what are the,
you have 1 minute to conclude your presentation.
okay, sir. So these are the results. All these results are compared with the previous results. So here I'm taking the batch, every time the batch size is, I'm taking the 32 as an input. So I applied epoch size is 50, and the loss function is categorized the cross entropy. And the here I'm taking the total, result, whatever I'm taking the data set is 4,000 change I applied for the data sets. Here I found that the gray leaf spot is F1 score is 0.98 accuracy I got, and common rust is 0.98 I got. Northern leaf blight disease is 0.97, and healthy is 0.98 percentage. So finally I conclude that, so these are the comparative study and previously what the models are working on this problem, and how much training and validation accuracy they got. So mobile net, so ResNet, when compared with the remaining all algorithms, my proposed hybrid model, MobileNet and custom CNN giving the high accuracy than the remaining algorithms. So finally, I conclude that The proposed mobile net custom CNN hybrid model will effectively find out in the MISA disease classification by combining the deep semantic and task feature sectors. So finally, whenever this model is a very agriculture and diagnostic system for our model. Thank you very much.
Thank you for your presentation. Sir,
Thank you,
do
sir.
you have any questions?
Thing is, what is entropy in your result?
Sir, sir, your voice is little bit low, sir. I'm not getting.
Have you got the question?
No, sir. Can you
Okay,
repeat, please?
I'm repeating. Can you tell me the how many number of diseases you have considered for identification? The first question. And second question is, what is entropy?
Uh, Sir, entropy is a measure of uncertainty, sir. Uh,
Okay. And
uh,
how many
and
diseases you have considered?
sir, mainly in my data sets, it is three diseases, and one is healthy lives, sir. One is a blight, common rust, blight. These are the three diseases mainly I focused, and healthy lives also I'm giving as one of the data sets, sir. So four, there are I'm using four classes.
Okay. Okay, thank you.
Thank you so much, sir. Thank you, one and all.
Okay. Yeah.
So next we have Induma, paper title, A Systematic Review of a Quantum Machine Learning Models for Image
Mhm.
Classification. Induma, are you there? Okay. Next we have Abhijit Kumar, paper titled Comparative Analysis of Automatic Story Generators Leveraging AI.
Yes, I am here. Am I audible?
Yes, you are.
So am I allowed to share the screen? Is my screen visible?
Yes.
Okay. Good afternoon, everyone. Hello.
Yes, Abhijit, you can start.
Yes.
My screen is crashing all the time. Is it visible now?
No, it is not.
Okay. I will close. Hold on. I will close certain things.
Yes, now
Now?
it is visible. You can start.
Okay. So my topic is comparative analysis of automatic story generators leveraging AI. These are the topics we will cover. Recently, generative AI has been a very disruptive technology. AI is able to match humans in creative tasks such as generating video, music, voice, image, text, etc. However, AI requires a lot of powerful compute resource, lots of data, training time to achieve such feats. This work focuses on creative text generation in low resource environment. We built LLMs that generate story from keywords, and we compared them, all done free of cost, thanks to Google Colab's free tier. Objectives. This work aims to build and compare LLMs that will generate stories from user supplemented keywords uh, by completing the following objectives. Uh, we are to build decoder only RNN, LSTM with attention, transformer-based LLMs in PyTorch, maintaining similar parameter count. We are to train all the models on same text data set of short stories in keyword to story format. We are to compare the models by their training time, generation time, blurred score, and keyword coverage, while keeping the cost low as possible, preferably free throughout the process. And we were able to keep it free. Now, the motivations behind this work. We wanted to demonstrate that meaningful AI research can be done for free. We wanted to enhance and accelerate creative writing and content creation with the help of AI. We wanted to provide creative writers with lightweight alternatives to big AI models. We wanted to contribute to AI research and learn more about it. We wanted to see the quality and performance of small LLMs in low resource environments. Uh, we wanted to compare old architectures with new ones in modern text generation pipeline and hardware on a creative task such as story generation. Background. An LLM or large language model is an AI model that is able to generate text from user prompt. As you can see from this table, LLMs usually have large parameters, 5 to 10 billion or more, and required large data sets, 1 terabytes or more. Even small ones like GPT-2 is of 100 million parameters and is trained on over 30 gigabytes of text data set. Our models are much smaller, around 10 million to 12 million parameters, and they are only trained on 20 megabytes of text data set. First, now we will discuss the methodology. First, dataset preparation. We collected the text data from online text corpus. We collected it from Kaggle. We cleaned the text data set to reduce the complexities as much as possible. We transformed the data into the desired format of keyword to text format. Model development in Python using PyTorch library. We coded the model classes of RNN, LSTM plus attention, and transformer-based LLMs, inference function, and training loops. Third, model training. We initialized and trained the model on the same data set on Google Colab's free tier T4 GPU runtime, and we saved the weights. Then we evaluated and compare the model based on their training time, generation time, blurred score, and keyword coverage. We chose blurred because it's a learned evaluation metric that scores how close a generated text is to a reference, considering meaning, fluency, and grammar. It's better than older methods like Blue or Rude because it uses a pre-trained language model. And we would make more iterations, more versions of this models to make it better. Dataset description. We downloaded the Tiny Stories dataset by Devastator on Kaggle. It's of 20 megabyte size. It contains over 20,000 stories of 100 to 300 words. Just the stories, not the keywords. We had to first clean the dataset using regular expressions, getting rid of unwanted keywords. And to get our dataset into a desired format, we used Keeper to extract keywords automatically to entire dataset, which took 20 minutes on Google Colab. The keyword was used in this configuration, and after we transformed the dataset into our this format that is shown here. This is our overall design for every architecture. So basically, most of works in its way. First, words get converted into specific numeric IDs by tokenizer, which are called tokens. It goes through the model, and then model outputs a probability distribution, and from which we can use various methods to select which word should come next. We used greedy decode, that is the word with highest probability comes next. Finally, that word gets appended to the input, and the cycle continues until the max length is reached, or the model predicts the end of sequence token. Now, we can see in the image, we kept everything same for all the model, except that the core architecture layer will change because that's what we are comparing. This is these are the hyperparameters for all the models. We tried to keep total trainable parameters same as possible. So for the RNN model, it's 10.3 million. For the LS team, it's 11.5 million. For the LS team with attention layer it's 12.6 million, and for transformer, it's 10.6 million parameters trainable. Uh, all models use this custom sentence piece unigram tokenizer with 13,000 unique tokens. So that's its vocabulary. We use subword label to balance the size of vocabulary and sequence length. All the models, the training setup, all the models are trained for 10 epochs using Atom Optimizer with cross entropy loss and a teacher forcing setup, and training is performed on Google Colab's free tier T4 GPU. These are the evaluation criteria. All the models are evaluated by their training time for 10 epochs on the same runtime. Average generation speed for to generate 200 words, a blurred score on this test data set, and keyword coverage. We chose the keywords happy, giant, car, animal, cat to confuse the model, since such a combination doesn't exist in the training data set. Stories involving a car are extremely rare in the data set, and ones combining animals and car does not exist. After testing these models, these are the results. All the models generate 200 words in about 1 second. The training time of the transformer based LLM is the least, scoring the highest blurred score of 0.4004. We also put Chat GPT's OpenAI's GPT-4o to the blurred score test to see where our model stands. However, it does not score that higher, 0.4388, but it's not the fault of ChatGPT, because blurred measures how close a generated text is to the reference. So for a creative open-ended task, it's not the best metric. So it's a drawback of blurred. During keyword coverage test, this is the output of RNN, this LSTM, then the output of LSTM with attention, and this is the output of transformer. So for the given keywords, we selected the best outputs for each model. Only transformer model was able to generate a story that covers all the keywords most of the time. It transformer also misses at least one keyword occasionally, but most of the time it is able to cover all the keywords. Additional findings: temperature value of 0.7 was the optimal for all the models. Model tends to show inverse behavior of keyword, that is, order of keyword in the input would determine their importance in the generated story. For training, batch size of 1, models occupy less than 3 gigabytes of video memory. During inference, model take up less than 2 gigabytes of video memory. On Google Colab's CPU runtime, the models take about 9 to 15 seconds to generate 200-word story. We also created a demo interface using Grid.io. Implementing Google text-to-speech.
You have 1 minute to conclude the presentation.
So this is like an interface that would we could select our trained models, and it would generate text, and Google text-to-speech would also produce the audio narration of the stories. Conclusion: all the models were built and trained evaluated successfully free of cost on Google Colab T4 GPU runtime. Dataset was collected, clean transfer before the training. Models are capable of generating stories from input keywords. Models were evaluated based on their blurred score, keyword coverage, training generation time. Models inverse behavior of keyword. Transformer performs the best in all tests conducted, scoring 0.4004 in blurred metric. Feature scope: these hyperparameters can be tuned for bigger models, to make bigger models. they can be trained on larger data set. If data set for different languages are available, we can train it on that. These model can be trained on other tasks, not just the keyword story generation, as long as the dataset exists. So these were the challenges. Thank you for allowing me
Thank you
to
for your
talk.
presentation. Sir, do you have any
Yes,
question?
yes. Thank you for the presentation, Mr. Rana. Two questions for you. First one is how many hyperparameters you have identified, and second one is why LSTM average time is less as compared to the transformer.
Well, I will answer the second question first. So
Yes.
the pure LSTM doesn't have the attention mechanism, whereas the transformer has the attention mechanism. So the attention mechanism generates like a Curie key value pairs. So it takes about big O of n square time complexity. So that adds up a little bit.
Okay.
And the first question was how many hyperparameters? Well, it
Yeah.
depends on the model. I don't recall it properly. I will go back to the table. Can I go back?
Okay.
So those that are NA, not applicable, that means it doesn't exist within the model. So let's say for RNN, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hyperparameters for RNN. For transformer, it would be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So
So
it is
these what
related
we
to the
have
input
identified.
keywords.
These we have identified. We
Yes.
if we make like a more complex model, there can be more.
Okay. Thank you.
Thank you, sir. I appreciate it. So I stop sharing.
So next we have Juhi Shah, paper titled "A Dialogue Systems Through the Decades: A Survey of Taxonomies and Shifting Paradigms."
Shall I share my screen?
Yes, you may please begin with your presentation.
Is my screen visible and am
Yes.
I okay? Good afternoon, everyone. I'm Juhi Shah. The title of our survey paper is Dialogue Systems Through the Decades, a survey of taxonomies and shifting paradigms. This is the outline. This presentation reviews historical evolution of dialogue systems with major architectural paradigms, then proposes a taxonomy of dialogue systems, and later concludes with future directions. Now, dialogue systems are computer programs that can communicate in natural language like English, Gujarati, Hindi, or any human language that it is trained upon. We popularly know them as chatbots or conversational agents. We encounter them everywhere across many websites and applications, from online food ordering, personal assistants, to healthcare. Now, the global chatbot market is projected to reach 46.6 billion by 2029, from which North America significantly contributes 40%. Now, there are more than 8.4 billion voice assistants already present worldwide. That means they have already surpassed human population. Therefore, it's very important to study dialogue systems. This diagram gives an overview of historical evolution of dialogue systems. These systems have evolved through various paradigms driven by these technological developments, which were possible because of computation, data availability, and user expectations. So the early dialogue systems like ELIZA were rule-based. Then later statistical and modular approaches followed, and recently large language models have reshaped this field greatly. which I'll discuss in upcoming slides. Now, the earliest rule-based dialogue systems relied entirely on handcrafted rules. So they could only respond to those inputs they were explicitly programmed to recognize. So there was no learning from data and they were rigid. Then statistical and machine learning approaches uh, matured and dialogue systems moved towards a modular architecture. So there were separate components for accomplishing separate tasks like speech recognition, intent detection, etc. So what was the problem is if there was error in any one module, suppose intent was misclassified, then that error was passed on to the entire pipeline. Then, deep learning enabled end-to-end dialogue modeling, where sequence-to-sequence architectures with attention mechanisms allowed to generate more fluent, more natural responses. Single neural network was used to map inputs directly to outputs. So there were more fluent responses, but still they were irrelevant and inconsistent. Then generative foundation models are basically large language models pre-trained on vast variety of data like news, books, or all over the internet, blogs, some websites. But these type of models tend to produce factually incorrect data. They may cause hallucinations. To address these factual errors, retrieval augmented generation was introduced, where they could access external knowledge base to retrieve appropriate information before generating responses. So as this became a two-step process, it was slower and more complex in architecture. Then prompt learning gives task instruction in the input prompt itself. So the model does not need to be trained again for different tasks. They can be guided from the instructions given in the input prompt itself. They are sensitive to prompts as any changes in the wording can change the output completely. So they were unpredictable and prompt sensitive. In practical scenarios, hybrid neural systems are deployed where they use a combination of these paradigms and able to generate and retrieve both at the same time. But these kind of systems are complex in architecture. Now, all these are deep learning based paradigms. So one may think that they might be using the same encoder, decoder, or transformer kind of model in each of these. Then what is the difference? So the difference in how that model is used. So end-to-end system and foundation models are limited to training data, but their scale and capacity is different. End-to-end systems are mostly limited to data related to a task or surrounding a subject area, whereas foundation models are pre-trained with large data. Then retrieval augmented data and prompt learning have some amount of knowledge grounding. Like retrieval augmented generation can access external database to verify the information before generating response. Whereas prompt learning has access to instruction given in task so that you don't need to train again for a new task. So both of them have some data apart from training data, something outside their model parameters. Dialogue systems need to perform several smaller tasks in order to understand user and respond efficiently. So first, intent classification helps the system understand what the user wants to do. Suppose it wants to book a ticket or order food or just wants to answer a question, wants an answer for a question. Then slot filling extracts important pieces of information from the user's message that are required to fulfill that goal of the user. Then dialogue state tracking keeps track of everything in the conversation, such as user goals, extracted slots, history corrections systems, then response generation will decide what the system should say next. Many times, dialogue system also use external knowledge data to fetch information needed to answer user queries more accurately. Finally, personalization and emotional recognition. This allows the system to adapt to users' tone and emotional requirements. This is the mapping of dialogue subtasks with the architectural paradigms and dialogue systems. So the early rule-based dialogue systems like Aliza, Perry, Jabberwocky used fixed patterns to generate fixed responses. Then statistical and modular approaches are able to perform, as they have already separate components, they are able to perform all these dialogue tasks. Now, end-to-end neural networks are just single neural network. They don't have any component, directly maps input to outputs. They do not have a separate component for remembering context. But the way they are modeled, the conversation is encoded and fed to the uh, architecture. They have some amount of implicit context modeling. Generative foundation models can handle longer context, implicit intent understanding, dialogue management, and personification. Retrieval augmented generation is used for uh, generating valid, factually correct responses. So they in turn increase the reasoning accuracy as well. And prompt based,
You have 1 minute to conclude your presentation.
okay. Uh, we have proposed this taxonomy based on different attributes of dialogue system, like the underlying algorithm, then it's rule-based, retrieval-based, or generative. Then depending upon the knowledge-based and application, if it is task-oriented, then it would have a database related to a task or a particular subject area. So depending upon knowledge base, it would be closed domain dialogue system, and depending on application, it would be task-oriented dialogue system. Whereas if it is not related to a particular task and the system wants to engage users, then those systems would be called social bots, and they would be trained with large amount of data from news, movies, sports, and those would be open domain systems. Similarly, based on contextual history and number of participants, they can be single turn conversation, multi turn, or depending upon one-to-one conversation or group conversation, they can be dyadic or multi-party dialogue systems. Dialogue systems have transformed from deterministic rule-based to reasoning-based LLM-driven agents. Our survey offers unified understanding of this evolution, presents a taxonomy, highlights the limitation and emerging trends. Looking ahead, the research is more focused towards factually grounded and controllable models, safer, transparent systems, rich multimodal interaction, and emotional aware personalized assistance and multi agent collaboration. These are the references. Thank you.
Thank you
Yes,
for your presentation. Sir, do you have any questions?
yes, nice presentation. Madam, I have two questions. One question, first question is whether your dialogue system is user dependent. This is the first question. And second is in the dialogue generation, what is the basic or what is the major objective of dialogue generation?
Um, This is actually a survey paper, so this does not cover implementation, but the generation depends on the application of the dialogue system. Whether if I want to book online tickets, then it would be based on that particular task itself, and it
Okay,
would depend on the user uh, requirements.
okay, okay. Thank you.
Thank you.
Now, next we have Neetha. Paper titled Distilling sentiment leveraging high resource models for low resource language. Neetha, are you there?
Yes, am I audible?
Yes, you may please begin with your presentation.
Yeah, just give me a second to share my screen. Hello, I think I'm facing an issue with sharing my screen. I'll have to quit Zoom and reopen. Is that okay?
Okay. So next we have Nilesh, paper titled Forecasting Indian Foreign Exchange Reserves Using Machine Learning, a Random Forest Approach.
Hello, am I audible?
Yes. Okay, Nita, you may please start.
Yeah, thank you. Um, explore how knowledge distillation can be used to transfer knowledge from some large multilingual models to some smaller, efficient models which are suitable for real world deployment. So basically, NLP progress is heavily skewed towards English because most advances in NLP today are centered around English, which benefits from large datasets and extensive tooling. But in contrast, Indic languages like Hindi and Kannada, which remain low resource, despite their use by millions every day because of lack of datasets. And in real world settings, users often write in Romanized scripts, like mixing English with the native language, which has a lot of spelling variations and informal language that's being used right now. At the same time, large transformer models are computationally very expensive, making them very difficult to deploy in practical systems. And this motivates the need for efficient and inclusive sentiment analysis models. So our problem is to perform sentiment analysis for both Hindi and Kannada under some realistic constraints, which is limited label data, script diversity, and also deployment limitations. So the key question that we ask is, can we retain the performance of a large multilingual model while making them lightweight and deployable also? And we address this issue using knowledge distillation. So what we do is we take a large multilingual model, which is XLM Roberta in our case, and we use that as the teacher model. We use some smaller student models that learn from the teacher's soft probability outputs rather than just hard sentiment labels. So this allows the student models to learn richer decision boundaries, which is especially helpful in low resource settings. So this is our system overview. We start with some real world data collection, followed by pre-processing and class balancing. Tokenization is handled differently for native and Romanized scripts, after which contextual embeddings are generated. For Romanized scripts, we use a rule-based tokenizer wherein it mainly depends on punctuations and different words. So next, the teacher model is tuned first, and then its outputs are then used to train student models through knowledge distillation. Uh, so we collected data from some real world sources like YouTube comments and GitHub commit messages. The data was manually classified by us into positive, negative, and neutral sentiments. And since the data sets were noisy and imbalanced, we performed extensive cleaning and applied combination of oversampling and undersampling to balance the classes. Now the teacher model outputs soft labels, which are like probability distributions over sentiment classes. And now these soft labels capture not only just the predicted class, but also the teacher's confidence. And this helps the student models learn inter-class relationships. For example, that neutral sentiment lies between positive and negative, and that helps us to generalize our results better. So these are the results that we achieved. XLM Roberta achieves the highest accuracy because it's a pretty large model, having around 12 layers in its transformer structure. But we also found that it's pretty large and slow to deploy. And among the student models, which are Distilbert, TinyBert, and MobileBert, Distilbert was found to have the best trade-off. It has around it has around 6 layers. It lost only about 5% accuracy, but the model size was reduced by more than half. And now MobileBert is the smallest and the fastest, not that accurate, but it makes it very suitable for latency critical applications. Overall, knowledge distillation works well for lower source Indic languages. While native scripts perform better, Romanized text still achieved a good amount of accuracy, indicating good generalization despite some noise. So, to conclude, our work shows that efficient and accurate sentiment analysis for Indic languages is achievable through knowledge distillation. Thank you.
Thank you for
Yes.
your presentation. Sir, do you have any questions?
Yes. One question for the Ms. Malya. In your this distillant model, you said that the size is what we can say minimum as compared to the first model which you have compared. So why this size is minimum?
Sorry, sir, I didn't get your question. The site it's
Yeah.
already a pre-existing model that we used. So Distilbert is a transformer model with
Um,
6 layers in its architecture.
okay. So what is your contribution?
My contribution is basically writing the code for these and running the scripts, along with some amount of tuning and regulating the epochs.
Okay. Thank you.
Thank
I have
you.
done.
Next, we have Nilesh, paper titled Forecasting Indians Foreign Exchange Reserves Using Machine Learning, a Random Forest Approach. Nilesh, are you there? Okay. So next we have Leo Raju, paper titled IoT and LoRaWAN based advanced building energy management in educational buildings.
Yeah, good afternoon to all of you. So I am Dr. Leo Raju and my co-authors are Yogesh, Vasanta Krishnan and Sriram. And our title is IoT and LoRaWAN based advanced building energy management education building. Yes, good, next slide. Yeah, so the flow goes like this. And yeah, we have introduction, literacy survey, problem statement, objective. These are the flow of the presentation. Next slide. Basically, we have implemented energy management system in our department, in our college. So here every year we are paying a lot of money to the cloud to monitor our energy systems. So rather we thought that why we can create our own arrangements for monitoring our energy consumption in the department. So that way we have developed a prototype wherein we use LoRaWAN so that long distance communication is possible through it. So we try to monitor energy consumption in different buildings with LoRaWAN. So we just use LoRaWAN to communicate between one building and another building. We have 3-4 places we installed our LoRaWAN sender, and then receiver at the gateway. So all these loads, which is distributed across the different labs in the departments, so the loads can be monitored through the gateway in the end, receiver end. After that, if you want, we can use the dashboard to see the data. As of now, we have just monitored the data in our local server, which is used at the gateway. Later on, we have planned to, through gateway, we can go into cloud if you want the further view from the web. Because we don't want to spend every year for maintenance charges for this database centers. Rather, we just confine ourselves to local database so that we can able to see all the energy related information of our department, specifically here. That can cost cutting measures we develop. This is what about our projects. And we have used the local, the energy measurement unit, which is PZM 0440, and we use ESP32, and use the LoRaWAN sender and the receiver. So these are the few things used. And I asked Yogesh to carry forward this, to go ahead with this.
Okay. Am I audible?
Yeah, audible. Go ahead.
Yes, sir. So my co-author Sriram will continue from the literature review. Sriram, are you there?
Yes, I am there.
Okay. So continue from
Yeah.
literature review.
Good day to everyone. Our work integrates key findings from these studies. So the main authors are Ullman, Mendoza, and Claudia. Ullman validated combining IoT sensing with predictors for energy forecasting, while Mendoza RN highlighted the necessity of IoT solutions specifically for smart building applications. Claudia Yu and Morales provided a comprehensive study of the Modbus, which we have used in this project, and Isaac C. confirmed the importance of smart metering, especially in educational buildings. Next slide. Rapid urbanization is driving an urgent need for efficient energy systems. So our projects has a greater impact since it is overcoming the current limitations such as cost and wiring. Conventional installs are too expensive and complex. And the second most limitation is the data gaps. Distributed nodes often lack the real-time data needed for management. There are persistent constraints in the scalability, interoperability, and cost effectiveness of older systems, preventing economical monitoring in large environments like education campuses. Objectives. These are the main objectives of our project: to develop and implement a unified IoT framework capable of efficiently monitoring and managing energy consumption across a distributed environment, to demonstrate accurate real-time data collection across long distances in challenging environment, to design a scalable system using ESP32 and industrial-grade sensors for active sensing. I'm giving the mic to Yogesh GS.
Okay. Good afternoon, everyone. I'm Yogesh. I will be continuing this presentation. So let's move on to the proposed methodology. As you can see the above, this is the block diagram of the system. The ESP sends the signal by collecting the electrical parameters and sends it to the ESP32. This ESP32 is connected with the LoRa trans receiver, which is a RA02 module, which then transfer the data to the LoRaWAN gateway, which is a local database from which we can see all the electrical parameters from the distant locations. So this gives us a dashboard. This can be used for visualization of the electrical parameters to the consumers or any institutions. So moving on to the hardware architecture and component selection, we use certain hardware components such as ESP32 and LoRa trans receivers, which is the RA02 module, and PSDM 0040 is used to measure the electrical parameters, and also we used a commercial Celtec EM2M energy meters to measure the electrical parameters, and uh, these combine together to form the hardware architectures. So we program the ESP32 in Arduino IDE for simplicity. We can also use Platform IO if it has supports LoRa libraries. We also used Platform IO to show the result in the later slides. So ESP32 acts as a central processing unit which controls the sensor nodes, gateway, and responsible for data collection, processing, and transmission to the receiver ESP. So on moving to the hardware implementation, as you can see, this is the overall hardware setup of our system, which is later deployed in various locations. And this is how we configure the pins, as you can see from the slide. And each are positioned within our institution, 500 meters apart within the department building. And the subsequent prototypes were built and tested subsequently, and components were moved to the board to increase their reliability. So as you can see from the first picture, this is our receiver LoRa module, and the below you can see this is a 0040 PZTM module, and another in the right below corner you can see the Celtec EM2M module, which are the devices we used in this project to implement the monitoring electrical parameters. So that's the node 1 presented placed in the analog circuit lab, and second node is placed in the final year classroom, and the third node is placed in the electrical workshop, which is approximately 500 meters apart between each classrooms and labs. So the next move to the data processing. These after a PCTM or Celtec EM, after sending the data to the ESP32, these are formatted to a JSON packets. Then the nodes send this packet using the RA0 to LoRa transceiver module, and then immediately after transmitting, the node return to deep sleep to conserve power. So the LoRa is a long range, low power module. So after it's did its work, it immediately goes back to sleep to conserve power. This improves the efficiency of power consumption of power. So after sending the data, we just come for the receiver. So at the receiver side, the central LoRaWAN gateway is designed to be always on, listening for the LoRa packets from any nodes from at any time. So this gateway successfully receives and sorts the package from multiple nodes, even with the barrier in the way. So we can improve the signal strength by significantly by improving the antenna by going for the higher decibel gain antenna. For example, we can use a 5 decibel gain or 8 decibel gain antenna for longer distances to get better connectivity between the two nodes. So upon receiving the package, the gateway forward the data to the PC through USB connections, and then these electrical parameters are monitored remotely using the local server, and local server can accurately monitor data up to 2-kilometer range. So this use of local server for real-time monitoring makes the resource management economical for electrical campuses by reducing the cloud server changes and annual data charges. Because in our institution, we currently using a setup made by a private company, which takes several thousands to pay for them to monitor and for the annual maintenance. So by implementing these steps, we can actually reduce those costs, and we can invest it for somewhat later in better systems. So this is a system operation and result. So as already told, the sensor operation, it converts to it the PSDM Celtec EM2M sends the data to the ESP32. Then it converts to JSON packets. Then it sends to the gateway, and then gateway transfers the data to the PC with the help of the USB connections, and data are monitored and the data flow is given. So this gives us economical advantage. And validation, the sensor measurement from PSDM 0040 and EM2M were validated to be within the plus or minus 0.1 accuracy compared to the calibrator multimeter, and LoRa communication is verified to be reliable despite barriers. So these are the results. And as I already told, we use the ESP32, ESDM0040 LoRa modules. And this serves as a solid base for the future development. And these central gateways proved to be reliable, and data is forwarded to the PC through USB. And we used Arduino as well as Platform IO for coding and monitoring purposes. As you can see, this is a platform IO in VS Code. Here you can see the node 1 and node 2 packet received in the receiver sections from the transmitter node 1 and node 2. And this is a node 3. As you can see, these voltage, current, power, energy, and frequency and power factors, which is displayed in the monitor. And here's the clear view of all the data we received from all the 3 nodes we tested across the different locations in our institution. So this is for your reference. And then our institution already has a private infrastructure. As I already told, we have used a private company to already set up a power energy monitoring system. So we just redesigned our system to be used with the existing infrastructure. The existing infrastructure use is Celtec EM2M energy meters. So we just redesigned our system to be compatible with those private operators. So these are the result by making compatible with the EM2M energy meters. As you can see, the voltage, current, power, energy, frequency, and power factor. And you can see several different. You can see several like size, signals, raw data, and power factor and node strength. I will give the explanation to that in later slides. As you can see here, this is a packet reception. The output confirms a successful reception from the node packet 5, which is nothing but the replaced redesigned model of EM2M node 1, which is received at 12.6 and that is the time. And the packet size, the depth payload is 1 or 2 bytes. The signal received strength is to be minus 37 decibel meters, which is a very strong signal. And the signal to noise ratio is 11.8 decibel, indicating the excellent signal quality. And from this, we can access that the signal strength is excellent, and the node 5 is optimally positioned at the right place. So by this, we can also get the feedback from the system to improve our connectivity between the 2 nodes. And these are the data from the
You
modified
have 1 minute
EM2.
to conclude your presentation.
Okay. These are the modified system. These are data from the modified system. So moving to the results and discussion, we chose LoRa over the Wi-Fi, and this gives the economic advantages for an institution, and it is proved. So this is suitable for distributed infrastructure for remote or rural location where high-speed internet connection is not limited, or wired connection is not possible. So the proof of concept for sustainability is proved. This is a low-cost, scalable, reliable resource monitoring system, which is built using the new embedded system for long-range wireless technologies, contributing to the sustainable goal worldwide. And moving to the conclusion, as I already told, this is a LoRa-enabled IoT platforms for for comprehensive energy monitoring as for successfully implemented testing within the department building. It's a low-cost, scalable, reliable resource monitor. Data transmitter from the sender nodes to the central LoRa receiver is successful and can be monitored in real time, and is highly economical for a education institution to allow them to considerably reduce the cloud server charges and annual maintenance charges. So our future work includes to extend the systems and further focus on software development to enable deeper analysis, and system can be extended to utilize the collected data and to contribute to the sustainable goals worldwide. And our system can be also be introduced to the AI and machine learning for more accuracy. And the successful demonstration suggests that the next step is to scale up the system to produce the world change in real world energy management approaches. So these are the reference we use to refer, and this is for your reference. And then thank you.
Thank you for your presentation. Sir, do you have any question?
Yes, nice presentation, very detailed and very complicated also. I have one question. In your energy management, are you focusing on only the certain type of devices or all types of energy consumption devices?
We consider all type of devices. Especially, we have a lot of classrooms, the tube lights and fans in the classrooms, as well as the electrical machines lab. All the labs, we consider all the labs in all the classrooms, all the faculty rooms as well, sir. The department.
Okay, so the all devices are being connected with your LoRa Wi-Fi
Yes, sir.
sensors. Yes.
Yes, sir.
Okay. Yeah. Nice work, sir. Thank you.
Thank you, sir.
So next we have again Leo Raju. a paper titled IoT-based real-time energy monitoring in academic buildings.
Okay. So good afternoon to all of you. This project is basically the continuation of that. As we are in the process of establishing our own energy management system, our department, we want to, segregate separately. So actually, we want to use the single energy meter, and we want to measure how much energy consumed by different loads, like 2, 3 bulbs we used it, and we want to develop a dashboard to show all the energy measurement parameters in the dashboard. So main thing is that only. So for that only, we have used an energy meter, smart energy meter, and then we have communicated the energy meter with the ESP32. As the energy meter is not compatible with ESP32, we have used the TTL converter. Basically, we use Max 485 because this energy meter will give you RS 485 in a Modbus communication. That has to be converted into TTL communication to be compatible with the ESP32. For that, we used Max 485 converter. To convert after that, that will be given to the Wi-Fi and to the dashboard. We use some cloud to use the dashboard here. In order to know how these different loads, data, electrical parameters are can able to measure in your dashboard. For that only we've used this project, because we are doing the big project. This is a testing project wherein we want to test individual energy meters and then different loads, local loads, and how we want to develop the dashboard, how we have to communicate with the energy meter with the ESP32. There's a lot of learnings we had in this project, and the students will explain about this now. Yes.
Good afternoon, everyone. The contents of this presentation will be the first we'll go through the literature review, then the objectives of our model, and then the proposed architecture of our model, and then the main hardware components used in this project, and then the circuit implementation, then the data acquisition system, and then finally the dashboard visualization. First, introduction. As Sir told, the main objective of this project is that as we know, in educational institutions, there are multiple electrical equipments. In conventional metering systems, what happens is at the end of each month, the amount of energy consumed will be recorded in the energy meter, and based on the amount of energy consumed, the tariff, the bill we will receive the bill. But the main problem in this is we cannot visualize the real time power consumption, and also it leads to the unnoticed wastage, and it leads to lower efficiency. So we have developed the IoT based energy monitoring system, which will help us to monitor the electric power consumption and various parameters in real time, and it's based on the observed parameters, the required actions can be taken. First, we have reviewed several literatures, and we have found several gaps in those literatures, and we have worked on those to develop our project. The first paper is titled AIoT based smart home energy management system. The main aspect of this project is it combines AI and IoT to predict the energy consumption and automatically control the appliances. The main gaps found in this paper was it uses complex AI methodologies, and it is more suitable for home rather than educational and academic institutions. Also, it does not use direct Modbus communications, and so the latency is high. The next paper is titled Design and Implementation of IoT Solution for Energy Management System. The key aspects of this is it uses real-time IoT-based energy monitoring and control. It uses ESP32 and the offline ESP now backup. The main gaps we found in this paper was it provides a generic architecture to the integration of the system, but it does not monitor the precise data monitoring, and also it does not explain the interface between the energy meter and the ESP32. And then the next paper was Energy Management and Anomaly Detection in Condition Monitoring for Industrial Internet of Things. It mainly focuses on ML-based algorithms to detect the abnormal energy consumption patterns. This system used very costly components, and it also is focused more on aftermath of the energy consumption. So we consider all these gaps in our project, And so we developed the system which is able to monitor the power consumption in real time. Next, the main objectives of our project are the real-time energy monitoring, and we aim to make a cost-effective solution that can be easily implemented in educational institutions so as to monitor the power consumption in real time and actionable insights. Or we have provided the system so as to, if anyone, the staff or students, anyone can log in using the credentials so as to access the power consumption and the dashboard. And then it is a very simple system. We don't need any too many extra components. It is suitable for already existing smart energy meters. And then remote accessibility. The power consumption of a particular place can be monitored from anywhere in the world through the cloud. Next, this is the proposed architecture of a system. The main component of the system is the energy meter. The smart energy meter will record the real-time energy power consumption parameters of the load, and then the data from the energy meter is transferred to the TTL converter. In this case, we have used the MAX 485 module. It is used to convert the RS 485 signals into the TTL signals, which is compatible for the ESP32. So the data from the energy meter will then go to the ESP32 through the TTL converter. The ESP32 has an inbuilt Wi-Fi system, Wi-Fi communication system. So the ESP32 receives the data from the energy meter, and then from the energy meter, the ESP32 will transmit the data to the cloud through the Wi-Fi. So we know most of the educational institutions have Wi-Fi connection. So we don't need any extra setup for this. So the ESP32 can directly share the data through the cloud through the Wi-Fi, and from the Wi-Fi we can fetch from the cloud, and from the cloud we can fetch the data to present it in a dashboard. This is the main hardware component of our model. It is a EM2M single phase select energy meter. The capacity of this energy meter is it can measure up to 100 ampere, and the communication system is it uses a Modbus RTU communication, and it uses RS485 type of Modbus communication. It can monitor various parameters like voltage, current, power, energy, power factor, and frequency. These are the parameters we have chosen to display on our dashboard. It can also monitor other parameters like the real reactive power and all on the other parameters. The next main component is the MAX 485 module. This is the differentiating factor of our project from the other projects. The main reason is the main purpose of this module is to interface between the industrially available smart energy meters and the ESP32. The main reason is because the smart energy meter uses RS485 Modbus communication. It has two wires A and B, but the ESP32, as we know, it works on TTL UART logic. So as to interface between these two, a signal conversion has to take place. So as we see in the converter, the right side pins, data pin A and B are connected to the smart energy meter. This module receives the signals from the energy meter. It is Modbus signals, and then it converts the signals into TTL signals, which is present on the left side of the input and output are present on the left side of the module. So by the signal conversion, we can ensure that the data acquisition is extended over long distance without even in noisy environments. This is the circuit implementation and the connection. We have shown the model connection of our system. As we see in the energy meter is connected to a single phase supply. In the sample, we have connected a single lamp load in the above image. So when the lamp is turned on, the electrical parameters like the current and the other parameters will be recorded in real time in the energy meter. The energy meter will send the data to the MAX 485 module through the RS485 communication, and the MAX 485 module will convert it into the TTL signal and transmit it to the ESP32. The ESP32 has an inbuilt Wi-Fi module. So through the Wi-Fi, it will transmit the data to the cloud, and then from the cloud, the data can be fetched to visualization dashboard. And we have also did this experiment, and we found the latency and other parameters using multiple lamp loads in the next picture. Now Ramanuja will continue.
Good afternoon. This slide explains how our system collects, processes, and uploads real-time energy data. Our data acquisition begins at the EM2M energy meter, which communicates using RS485 Modbus RTU. Every 10 seconds, the ESP32 reads parameters like voltage, current, power, energy, power factor, and frequency. Before sending this data out, we apply CRC 16 error checking and a basic possibility test to ensure that only valid readings are accepted. Once verified, the ESP32 formats data into JSON and transmits it securely to the Azure IoT Hub using MQTT protocol with TLS encryption. We use SAS token authentication, ensuring that only authorized devices can send messages. Azure IoT Hub then enroutes the incoming data into Cosmos DB, where every record is stored with the device ID and timestamp, enabling fast retrieval and historical analysis. Overall, this pipeline ensures real-time, secure, and reliable energy data transmission from the meter to the cloud.
You have 1 minute to conclude your presentation.
Once the data reaches the cloud, users can visualize it through a web dashboard. Our dashboard is built using Spring Security for authentication. Users must log in with valid credentials before accessing the Power BI dashboard. Line chart shows the trend of voltages, power over time, and can be extended to show how other parameters like current or power factor. This gives laptops and administrators a clear view, a live view of building's energy consumption at any moment. This graph shows the power versus time graph of the line chart, and this is the voltage versus time graph using a line chart. The result and conclusion: we have achieved real-time monitoring of all 6 feeders with less than 4 seconds latency. This entire pipeline from ESP32 to Azure uses TLS 1.2 encryption, and data is stored immutably in Cosmos DB. A secure login system ensures only authorized users can view the dashboard. The architecture is scalable and enabling expansion to multiple buildings and hundreds of meters. Overall, we have built a production-ready IoT energy monitoring system, integrates hardware, cloud, and security in a unified solution. Our system also provides a strong foundation for future upgrades. We plan to incorporate AI and machine learning to predictive anomaly detection and equipment failure alerts. Blockchain can be used to ensure tamper-proof storage or automated energy billing. A prescriptive monitoring engine can provide recommendations such as optimal usage time and peak demand alerts. We also aim to implement gamification reward low-consuming labs or hostels with energy points or carbon credits. Finally, the system can be extended to a large industrial motors for vibration analysis, power quality monitoring, and predictive maintenance. These are the references of our projects that help for our projects. Thank you.
Thank you for the presentation. Sir, do you have any questions?
Yes, one question. As per your future enhancement, you mentioned that blockchain security we can have in implementation.
Yes.
So can you elaborate this? How blockchain can be used?
So actually, we are going to measure the energy consumption by individual faculties. How much energy consumed. Then we have to store it. We have to tamper-proof data. Based on that, we were planning to provide incentives to the faculties who consume less energy for year basis. Like that, we have planned to give incentives so that we encourage people because sometimes you see faculties are out of room, still their AC, all things is on. Students are out of the class, still AC, fan and tubes are on. Like that, so many things are energy wasted in so many ways in the department. So we talked to our HOD and to create an incentive system to faculties who consume less energy by calculating using blockchain. We're going to temper data for every year storage of the faculty. So they'll be awarded accordingly. For that only we use blockchain, sir.
Okay, I got it. Thank you. Thank you all.
Thank you, sir. Thank you, sir.
Next, we have Kanchan, paper titled Remote Work Fatigue and Engagement, applying the JDR framework to understand employee performance in the digital era.
Hello, can you hear me?
Yes.
Yes, thank you. I'm Dr. Mugdha Kulkarni, and my co-author is Dr. Kanchan Patil. We will be presenting our paper. My screen is visible?
Yes, you may please
Yes.
proceed.
Thank you. So our paper title is Remote Work Fatigue and Engagement, Applying JDR Framework to Understand Employee Performance in Digital Era. So introducing the topic these days, remote and hybrid working has transformed the business function and how individuals see their jobs. Now, when it comes to remote working, it has become a permanent part of our organizational cycle. Now, with increased remote working, it has also increased the autonomy, flexibility, easy to access the opportunities, but there is always a limitation that the employees who choose to remotely work, they often see an misbalance between their professional and the personal life while maintaining 24/7 connectivity. Now, these increase of pressure can also create a psychological pressure on the minds and emotion, and that is why our research needs to know what are the remote work which affects the engagement of the employees, the mental protection if is enhanced, fostering the trust and openness with the remote work environment. This might help uh, help employees be interested in motivating. Uh, uh, Sorry, is it okay? Should I continue? Hello? Hello? Hello?
Yes.
Yes, continue.
What happened? Okay, yeah. Uh, s- um, so so this paper explores job demand. So this paper explores job demand resource model, which is job demand and job resource, supporting the factors like autonomy and the workload, examining the relationship between both of them. So continuing with this. Okay. So our research questions are: how do remote job demands and resources affect cyber fatigue, engagement, and employee performance? What are the rules of cyber tiredness and engagement, which play a link between job characteristics and job performance? So we are trying to basically see how job demands, remote job demands, like techno stress or work home interference or role ambiguity or cognizant load or a social isolation affect cyber fatigue and remote worker performance. To examine how remote resources, maybe autonomy or the digital support which the organization gives, supervision of the manager, the skill utilization, or even the psychological safety which probably given by the organization, can it actually improve the engagement and the performance? And to examine how cyber fatigue and engagement mediates the remote work features. So this is our conceptual model, which is based on GRD framework. We are saying that techno stress, work from home interference, role ambiguity, cognizant load, isolation leads to remote job demand, and autonomy, digital support, supervision, skill utilization, and psychological safety are the resources for a remote job, which might the demand what remote job is having might lead to cyber fatigue, and the resources which organization is provided might help them to keep it engaged. A balance between this will be actually affecting the performance of the employee. These are the hypotheses based on the conceptual model. Some of our review of literature is remote job has changed the work responsibilities, including introducing the new psychological and cognitive success that employees well-being or maybe the performance. So it might at times hinder also, or it might help also the employee to enhance the performance. Cyber fatigue, some of the ones which are talking are our cyber fatigue helps when technology demand or drain the energy, leading to lower efficiency. So engagement characteristics by state of rigor or enthusiasm or absorption or motivation of the workers can lead to the performance also. So there are many researches, review of literature, which talks about excessive autonomy or digital infrastructure. If the organization is providing a good infrastructure to an employee, it might end up having a better engagement and the performance later. the organization's trust which they hold on the employee, that okay, fine, it is a work from home, and they believe that they will be working from home for whatever allowed period. So the utilization, the safety, sometimes it also happened to the employee that they feel socially left, since they don't have this casual talk or peer members around, and they think that in the virtual meetings at times they feel left, might affect the performance. So our methodology, we have used empirical data analysis, which is analyzed by PLS. So we have sent almost 350 survey, and 269 of them were actually taken. So this is what is our demographic. And we have done the data collection on the questionnaire based on Likert scale. This is our construct validity, showing it has the Cronbach alpha is greater than 0.7, and the threshold levels are met. Our table shows that dimension were excellent, and the internal consistency and the convergent validity, since Cronbach alpha and composite validity both showed a greater than 0.7. The item has met the conversion requirement, and also AVE, that's our average variance extracted. This has also was greater than 0.5. This means that the accuracy represented the latent construct were used, and were used by PLS structural analysis. All these diagonal square roots, if you can see this, all diagonal square roots are all greater, is a higher value in the internal construct. This shows that the discriminant validity was also true, showing that each construct looked different in the model. So there was no multicollinearity that validates that the validity of discriminant is very high. Our R-square model, when it comes to cyber fatigue, it was 0.57. So 57% was concluded for cyber fatigue. 61 for employee engagement, and performance was 69% using this GRD model. So hypothesis testing, these were our hypotheses which were tested, and the beta values. So if you can see, almost most of them were supported. But we also found that remote job resources, cyber fatigue and engagement did not support much, and cyber fatigue and performance also partially supported. So it is basically because the result which was shown, the techno stress or home interference, ambiguity, or social isolation support very strongly or significantly. Autonomy, digital support, supervisors, assistance skill, and psychological safety impacted the distant work resources. Because it is psychological safety and supervisor, if at all they are the manager is giving is providing a touch during the virtual meetings, and taking into care all the problems of the employee, they typically do not feel left out. So this shows that the people requires emotional and structural help while they are far away from their co-workers. There is a relationship between remote demand and engagement, which was not substantiated in structural model, but when it comes to it is quite a demand. Sometimes it is quite a challenge, or challenging, because this challenges hinders the idea. Sometimes managers gives more work when it is work from home. It happens for the employee that it might be taken as a challenge than as a disadvantage in this virtual environment. Remote job and engagement demonstrated a robust support. The relationship of remote job and cyber was not significant, as I have shown. It indicates that resources alone may not help to actually help to elevate the performance. Cyber fatigue significantly determines affected by the performance, suggesting that elevated fatigue levels may substantially diminish if at all challenges are given to the employees. So So performance efficiency will be strongly affected by the same. So traditional job traditional job applications can be bit taxing and lead to reduced employee engagement. This findings indicates that distance work did not decrease the engagement, but may have increased it. It implies that not only expectation from the employees are not necessarily harmful, but it also serves as a challenge for the employees. From the viewpoint of a barrier, demand such as role ambiguity or social isolation hinders the goal achievement and diminishes motivation, whereas challenge demand may enhance promoting learning, competence, or achievement. In digital environment, we see that the work demands on engagement is not always same. It depends upon the personal quality also. So when workers have enough resources for their job, they are more likely to see their task challenging rather than tiring. Also, a negative correlation between cyber fatigue and performance remains somewhat significant, suggesting that prolonged exposure to digital technologies continue to impair the attention and efficiency. So workers maintain satisfactory performance and despite of their exhaustion, perhaps compensating the behavior or coping mechanism such as mindfulness or boundary management. So it is always good. The data suggests that fatigue does not consistently result in diminishing performance, particularly for the individuals who are technically proficient and genuinely driven. So this employees who are engaged demonstrated energy and commitment, resulting in an improved task. So our theoretical and practical implementation will help organization in complex characteristics to understand the demand in remote working, investing in digital infrastructure, providing supervisors with support, or fostering supportive environment for the worker can help to navigate the challenges, keeping them engaged and performing well. So concluding, the workers may become tired from work from home requirement, but employment resources might help them to accomplish it. Anticipating negative correlation between work expectancy and engagement was not seen, indicating specific demand are perceived as motivating challenges rather than the burden. So when workers view challenging digital tasks as an opportunity to learn, they may remain motivated as workload increases. So results extends JDR paradigm to remote work setting, underscoring the need for business to balance digital demand and sufficient support to mitigate fatigue or enhance overall performance of the employees in this virtual environment. These are some of our bibliographic work. Thank you.
Thank you for your presentation. Sir, do you have any question?
Yeah, I have one question.
Yes.
Okay, first of all, nice presentation.
Thank you,
Dr.
sir.
Pujari ma'am. Can you explain how to evaluate the employees' tiredness through digital media?
So the tiredness we have considered cyber fatigue. We have considered the things like when it came to cyber fatigue, we said technology or working from home, which is where the independent or they are or socially isolated. So on that perspective, we have or cognitive load what an employee typically has. We have considered these construct to understand what is a cyber fatigue for them.
Okay. Okay, thank you.
Thank you, sir.
So now next we have Prajesh, paper titled Talk Mirror Language to Language Translation with Voice Preservation.
Yeah, 1 second. Let me share my screen. Yeah, so good afternoon, everyone. My name is Prajesh, and I'm currently studying at Amrita Vishwavidyapeetham in Bangalore, and I'm in third year. So this is actually a kind of a mini project which we thought of during our fourth semester, and I, along with my teammates Kritik, Rakesh, and Guru Shaishri, and my authors Nilima ma'am and Glaze ma'am. So let me just let you go through the contents first. So first is abstract and then introduction, then the system architecture about our project, which I'll explain more in detail when we reach that part of the PPT, and then pipeline flow and the speech recognition transition, which is the main part of our project, and speech synthesis and voice cloning, basically the result which we obtain from our project, and we are taking more examples in our research paper, but in this PPT, I will include it too. And next is spectrum analysis, what we analyze from the results, like what we obtain, what we obtain basically. And then translation accuracy is between two different models. We're trying to calculate a similarity between two different models, and then conclusion. So this is the abstract. So basically, our talk model is basically a fluent multilingual speech translation system designed for transparent voice replication. So what we do is we use basically four models. We use Whisper, Embart, which is basically used for translation purpose, and then next we use is Partial Mouth and Librosa, where we try to get the original messages, tone, and emotion. And we try to and high fidelity as well, which maintains original acoustic signature and emotional tone. So introduction. So let me get into detail of the project. So in this digital world, we can connect with any person in any part of the world. But there's always a language barrier anywhere. Like if you're trying to contact from person from Spain and to India, there's always a language barrier. And that's when translation comes into effect. Like if you want to convert something from our language to Spanish, that's when translation comes. So normal translation is always in robotic voice, very bland. But what we are trying, so what we thought, we tried, like if I want to speak something Spanish, my translation will come in English in a robotic voice. So we're trying to get my original language, like the same tone, the same emotion with the translated language. So that's what we thought of, and that's what we came up. That's how we came up with this idea. So this is the system architecture. Let me just go I'll tell you how the system architecture goes. So first is when the first we upload the audio first. When the audio is uploaded, that audio first converts to English text. That's with the help of Whisper, and then we use Embed to translate that text into a desired language, into Hindi, Tamil, Malayalam, etc. And that text again is using GTTS, which is basically an another model that converts into a robot voice, the bland voice, the normal translation voice. Then using that and parcel mode, which is again I'll explain what parcel mode does in detail later. So that we try to get the original voice, like my voice, with the translated audio output. And this is the pipeline flow. So I'll tell you how the pipeline flow is. First, Python, basically, you enter the audio file in MP3 format, and using Whisper, first it figures out which language it is, and then that's what Whisper does, and then it converts the extracted audio into a text format, into English text, and then Embed again translates it, and GTTS voice cloning. I'll explain that in further detail. So this is how I'll explain you. So yeah, exactly. Input audio signal, speech to text, which is has been Whisper, and then it converts to English text, like can you say this phrase? So the audio had can you say this phrase, and it's converted into text called can you say this phrase, please? And then if you want to convert it into Tamil or English with that text, it'll change that using Whisper, and it's basically an OpenAI model, pre-trained, and it's a deep learning model. And then after converting it, what it does is it's again that converted audio using GTTS, it changes into robot voice, like bland normal Google translation voice. Now that translation voice will be combined with partial mouth. So partial mouth is again a model which is specific for speech extraction. It's good for it extracts pitch, the intensity of the voice quality, and so that's what voice cloning does. It takes specific parts, the important part of the audio, and then it tries to clone with the original voice of my voice, basically. So this is an example of a conversion. So this is Tamil to Malayalam. So we upload an audio file, and that file contains a Tamil audio. In Tamil, it said the songs and film are perfect. And using Whisper, we converted that audio into the text. And now it asks like target language. And in this case, example, I put Malayalam. And then it converted that into text. and that text will be again converted into an audio, which is like Google translated audio, into using GTTS. Now that, with the help of the original audio, parcel mode will compare, and then we'll try to, it takes a pitch shifted variation to get the original audio. And this is again the same example, Hindi to Marathi. What is your name? And then it converts into Marathi. And then again, when you're using GTTS, and voice cloning again happens. So this is the spectrogram analysis. So the first one is basically the Tamil to Malayalam, and the second graph is basically the Hindi to Marathi. So what does is the MEL spectrogram basically, it tries spectrogram is basically a spectrum of frequencies of a signal when it varies with time. So that's what as you can see the pitch pattern and the energy levels of the original first in the first graph. The first one is a Google translated spectrogram analysis, and second one is a clone one. And if you compare both of the Tamil to Malayalam, you can see that it's the main part is still preserved. So you can know it's like main part is preserved. The second graph as well, the first one original audio spectrogram of Hindi to Marathi, and the clone audio is with the parcel mouth combined. So as you can see that it's the energy levels, the band pattern, it's preserved the same. So that's what we learned from the results we obtained. Now, this is translation accuracy is basically the translated output using the MBART. We're comparing that with Google translation, like the translated text from the original audio file translated text. We're comparing, and you can see like for different languages, you can see the comparison analysis. From Malayalam to Marathi, you can see the difference between 6.7%. So yeah, that's what the system was evaluated by comparing similar percentage with Google Translate as a benchmark. So in conclusion, you can see that there is the gap in cross-lingual communication by prioritizing not just linguistic accuracy, but the preservation of human vocal identity. So the first voice preservation, we're trying to get the emotion and the tone. Next is real-time accessibility, and you can download it, you can play back, you can do, you can check, you can rewind it, fast forward it, etc. And key applications you can use in film dubbing, education purposes, customer care, and future scalability. And this thing can be integrated with big companies, like big companies, and doesn't have to be any big changes. Only minor changes is required, and it maintains privacy and performance as well. And yeah, thank you.
Thank you for the presentation. Sir, do you have any question?
Yes, Prajesh, nice presentation. Being a third year student, you have done a good job. Now, question is, you have mentioned your mirror talk. So, what is the role of mirror? Do you require really a mirror, or you can have also a camera also in place of mirror?
No, mirror talk is just a phrase. So mirror, when you look at yourself, you again look like you can see yourself, right? So the same thing when you're implementing and giving an audio file and in English language, and if you want the same audio file in Tamil, so that's just basically like a mirror, right? So that's what we're trying to do. We're just trying to get the same output back. It's just like an idiom if you
Can you tell me any inbuilt libraries, translation libraries are you using?
Yeah, we're using MBART, which basically translation library, and we're using Whisper as well. So the MBART is by Meta, Facebook. It's an AI model. It's a pre-trained AI model. So yeah.
Okay, good. Thank you.
Yeah, thank you.
So next we have Induma. Paper title: A Systematic Review of Quantum Machine Learning Models for Image Classification.
Good evening to all. My screen is visible, sir.
Your voice is too low, Induma.
Okay. Now it's okay?
Yes, now it's okay. Now please begin with your presentation.
Okay, so thank you. So good afternoon to all. It's our 10th International Conference on ICTCS 2025. My name is Induma Ilangovan. Under the guidance of Raghupati Rangasamy, my paper title is a systematic review of quantum machine learning models for image classification. This work reviews how quantum computing can enhance the image classification task beyond classical approaches. Classical machine learning, where it learns patterns. Sorry, sir. It learns patterns and relationships from data without being explicitly programmed. Classical machine learning can achieve high accuracy but struggles with high dimensional, noisy, and large scale data. Quantum machine learning introduces a new computational paradigm, superposition, entanglement, and quantum parallelism to address these challenges. It enables compact models with fewer trainable parameters while efficiently representing and processing complex and high dimensional data. The review systematically analyzes the state-of-art quantum machine learning for image classification, including quantum support vector machine, quantum neural network, and quantum computational neural network. Convolutional neural network. A key aspect in QML is quantum data encoding, which maps a classical image data into quantum state, which is the most crucial role in the image classification with the QML models. It has an applications like medical diagnosis, facial recognition, and remote sensing. A future research emphasizes non-resilient quantum models, efficient on struggles, scalable hybrid quantum classical architectures. Objectives of this review is to compare the state-of-art quantum machine learning models for image classification, to evaluate quantum data encoding techniques for NISQ classification, to review benchmarks and application-specific image data sets used in QNN, to identify key challenges, hardware limitations, encoding and optimization issues, to highlight future research directions for scalable and robust quantum image classification systems. Image classification assigns predefined labels uh, to learn images from based on color, texture, shapes, and patterns. Quantum superposition enables efficient encoding and parallel processing the high-dimensional image data. The parallel pixel manipulation achieved by processing multiple images simultaneously in quantum state. Quantum entanglement enhances feature extraction by capturing non-local image patterns. Quantum models such as QCNN reduce complexity, perform well in the noisy environments. Overview of quantum machine learning models for image classification. The figure shows that the types of quantum machine learning models, um, how quantum and classical models are used. Classical machine learning, classical data processed using classical algorithms, CNN on classical hardware. Quantum applied machine learning is nothing but a hybrid model. Quantum data analyzed using classical machine learning techniques. Quantum enhanced machine learning is nothing but a QCNN and QSVM, where data is processed with the quantum algorithms. Quantum generalized MLS is both the data encoding and learning are performed entirely using a quantum systems. Workflow. These are the workflows. First, preparing images with resizing and normalizing to convert the images for processing, and encoding into a qubits. Encoding methods like amplitude and angle encoding, which is used to map the image data into quantum states. After encoding, we build the quantum or hybrid models using use of QSVM, QNN, and QCNN. After that, train the model with the running quantum circuits and update parameters using classical optimizers. After that, we are measuring the outputs to classify the images and predicting the performance of the classifiers by the class evaluation metrics used like say accuracy. Quantum data encoding methods is the process of converting classical information into a quantum state so that it can be processed by quantum computer. Without data encoding, classical data cannot be used in quantum algorithms. So we are having some techniques like basic encoding, amplitude encoding, angle, tensor product encoding, quantum feature maps, The basics encoding maps binary data directly to bases of ket 0 and ket 1 of qubits, simple and efficient for smaller data. And amplitude encoding represent classical feature vectors in amplitudes of quantum states, which exponentially used in data points are represented in log 2 of n. And angle encoding embeds classical features into rotational angles. Each features can be encoded, making it practical for NISQ for image classification tasks. Tensor product encoding combines sub-features through tensor products to build the quantum state. It's mostly used in a QCNN to capture local and hierarchical image patterns. Quantum feature maps, which employs a parameterized unitary transforms to entangle the high-dimensional quantum space, which is used in the quantum support vector mission, used to boost the classification performance of a quantum image task. Support vector mission Support vector mission extend traditional SVM by leveraging quantum principles and quantum kernels to perform high dimensional computation and identify the complexities efficiently. Quantum SVM employs quantum kernels and optimizations, gives relationships in data and difficult for classification to mode. And these are the literatures of the QSVM and QNN. QNN are based on parameterized quantum circuits. The circuits parameters are trained to minimize the loss functions. It used was smaller to classical NN. It offers expressive power with fewer trainable parameters. These are the literature surveys for QNN. And quantum convolutional neural network. It is inspired by classical CNN and are designed for image classification. It reduces the circuit complexity while preserving important image features. QCNN perform well under noise and limited data conditions. These are some literatures on QCNN and VQC. VQC are widely used for classification tasks. Their approach or even exceeds the performance of their classical counterparts, combines quantum circuits with classical optimization. VQC is a quantum neural network based annealing and similar to the classical ANN technique. And data sets. Most studies use benchmark datasets such as MNIST and medical imaging datasets. These datasets are helps to evaluate the performance and feasibility of quantum models. The applications of quantum machine learning in image classification is medical imaging, satellite and remote sensing, security and biometrics, industrial inspection, and or agricultural environment. And limitations and challenges are limited and noisy quantum hardware, complex and costly data encoding, poor scalability to large data sets, training in instability, lack of standard benchmarks and real hardware validations. Conclusions. A quantum machine learning is promising approach for image classification, particularly in noisy and low resolution data. Quantum models such as QCNN, QNN, QSVM demonstrate a competitive with a fewer trainable parameters. The architecture effectively capture complex image patterns. Hybrid quantum classical models currently offers most practical and structures in NISQ hardware. Quantum feature extraction enhances representation while reducing model complexity. Efficient encoding of high dimensional and RGB image remains the challenge. Development of noise-resistant, scalable quantum architectures and encoding it is suitable for high dimensional, medical, satellite, and RGB images, establishing standard quantum native datasets and improved optimization to enable reliable benchmarks and real hardware training. These are some references.
Thank you for the presentation. Sir, do you have any question?
Thank you.
Yeah. Induma, can you tell me what is NISQ?
NISQ is a noise intermediate scalable quantum.
So, as per your this all literature survey, you have focused on the quantum machine learning. So,
Yes, sir.
what do you understand from this word quantum in machine learning?
it's already we are using a machine learning techniques, so we have to enhance some performance and speed up the training. So we are using the quantum machine learning models.
So it is basically for the performance optimization.
Yes, sir.
Okay. Okay. Thank you.
Thank you, sir.
Next we have Nilesh, paper titled Forecasting Indians Foreign Exchange Reserves Using Machine Learning, a Random Forest Approach.
അയ്യോ അപ്പാ വളരെ രണ്ട് ക്വസ്റ്റ്യൻ കേട്ടാரு.
Nilesh, are you there? Okay. I sincerely thank our authors for their excellent presentation and contribution in their session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during the 10th version and all previous 9 versions of the conference. We will be happy to have you in 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team ICTCS 2025.
Yeah. Thank you, sir.
So 2 minutes. Now, I also thank our session chair, Dr. Manoj Limchand Bangare, for chairing this session. A token of appreciation to their chair on behalf of Team ICTCS 2025, a global knowledge research foundation and partners. Thank you for your valuable presence. Sir, would you like to share a quick closing remark with us?
It was a nice experience for all 9 presentation, and also a great contribution by the all researchers, some doctors, professors in their field, whatever they have covered during their presentation. So I congratulate them again once again for the same, and also all the best for future endeavors and the research. Thank you all. Thank you, ICTCS.
I kindly request you all to switch on the camera for a quick snapshot of virtual conference. Thank you. Take care and stay safe.
Yeah, thank you.